All right, let's just jump right in. This is one of those scientific proposals that, well, it sounds like it's straight out of a movie. It's a mix of quantum mechanics, microbiology, and, get this, something you'd find in your garden.
So that leads to the big, kind of crazy question here. Could we actually build tractor beams out of pollen? Yeah, you heard me. Pollen. It sounds totally nuts, I know. But you gotta stick with me on this one because the science behind the idea is, well, it's just incredible.
So the whole point of this research, it's not just some thought experiment. The idea is to create a totally new kind of material. We're talking about a living, tunable metamaterial. So don't think of it like steel or plastic, something static and dead. Think of it like a living substance that can actually change its properties on the fly. And that, well, that opens up a whole world of possibilities.
And the places you could use this stuff, I mean, it's straight out of a Star Trek technical manual. You've got tiny tractor beams for manipulating things on a microscopic level. You have adaptive sails that could literally be pushed by light. And maybe the coolest one, a kind of starship skin that could actively change what it does, for sensing, for protection, you name it. It is wildly ambitious.
Okay, so what do you think you need to build something like this? Your mind probably goes to rare metals, maybe some giant high-tech lab. But the actual recipe they're proposing, it's a lot weirder and way more, well, natural.
Ingredient number 1 is empty pollen shells. Seriously. The reason pollen is so perfect for this is because of its outer shell. It's ridiculously tough, but it's also hollow and full of tiny pores. Nature basically handed us the perfect little container, a ready-made microbioreactor just waiting for us to fill it. All right, next up, you need the living part. And we're not just talking about one kind of bacteria here. It's more like a hand-picked microbial dream team. You've got conductive bacteria like Geobacter. These guys are great at moving electrons around. And then you have these special fungi that are amazing at soaking up light. This little team, that's the engine that makes the whole thing run.
So how do you control this thing? You might be picturing giant lasers or huge magnets, right? Nope. The whole system is designed to be powered and controlled by just light, and not even super intense light, plus a weak magnetic field. I'm talking about a field that's about as strong as the Earth's, the same thing a regular old compass uses.
Okay, let's recap. We've got pollen shells, a team of microbes, and a little bit of light. But how on earth does that create an actual physical force? Well, the secret sauce is this really cool, kind of weird bit of quantum physics, and we can actually wrap our heads around it with a pretty simple idea, a tiny light-powered compass.
This is the absolute core of the whole idea. It's called a radical pair. Here's what happens. Light smacks into a molecule inside one of the microbes, and it energizes 2 electrons, linking them together in this special state. Now, the spin of these linked electrons is the key. It is incredibly sensitive to magnetic fields. So sensitive, in fact, that the pair acts just like a tiny microscopic compass needle. Let's just walk through that real quick. A photon of light flies in, boom, it creates this linked electron pair. For a split second, that pair is like a tiny little magnet. And this is the magic part. An outside magnetic field, even a super weak one, can actually nudge that compass and influence which way it's pointing before it all falls apart. That little bit of steering, that's the whole game.
Now, one of these little quantum compasses on its own, it does basically nothing. But here's where the power of numbers comes in. Inside just one of these pollen shells, you have millions of these things being created and steered all at the same time, every single second. And when you add up all those tiny, tiny quantum nudges, you get a collective effect big enough to actually bend light and create a real physical force you can measure.
Okay, so if we've got the pieces and we've got the quantum trick, let's put it all together now and see how this becomes a single working system.
And it really is an elegant setup when you think about it. The pollen shell, that's the container, the body. The team of microbes inside, that's the living engine, the part that's actually making all those quantum compasses. And the light and magnetic fields, that's your gas pedal on your steering wheel. It's how you power it and tell it what to do. The researchers themselves put it in a really cool way. They say they're trying to engineer something that can mimic a gravity-like well. Now, to be clear, they are not actually bending space-time like a black hole or something. What they are doing is creating a tiny spot where light and particles act like there's a little gravity well there, gently pulling them in. And that's your tractor beam, right there in a nutshell.
Okay, this all sounds amazing, right? But a big idea is one thing. A good scientific proposal has to have a way to actually prove it or disprove it. So how are they planning to test if this thing even works?
They've got a whole battery of high-precision tests lined up. For measuring the forces, which are going to be tiny, they'll use something called a vacuum torsion balance. To see how it's bending light, they'll use really advanced optical measurement tools. They're even going to use mass spectrometry to check that the microbes are producing the right chemicals. And of course, this is all planned to happen inside properly contained, safe biology labs.
Now, in science, you're always paranoid. You have to constantly ask, is this effect real or am I just fooling myself? To deal with that, scientists design what are sometimes called killer experiments. These are the big ones, the make or break tests that are designed to prove once and for all that your idea is right and every other explanation is wrong. And they have 3 of these killer experiments planned out. First, they have to prove the quantum compass effect is even happening. That's the magnetomodulation test. Second, they have to show this new force isn't just something boring, like the simple pressure from light itself. The pressure curve test will handle that. And finally, the big one. Does this thing have to be alive? They'll compare living cells to dead ones to prove that the living part is absolutely critical to the whole process.
So let's just imagine for a second that it all works. The experiments are a success, the data looks good, the effect is real. What happens then? What kind of future are we looking at? Well, we kind of come full circle back to the beginning. All those science fiction ideas suddenly don't seem so fictional. Tractor beams you can use to move cells around or build tiny machines, that becomes a real engineering problem to solve. That idea of a living skin for a spaceship that can heal itself and change its job, that moves out of the realm of fantasy and into the lab. It would be a whole new frontier, a total game changer. And that really is the final, mind-bending question this research leaves on the table. You know, we think of technology as being made of dead stuff, metal, silicon, plastic. And we think of biology as, well, something that just grows. This work just blows that whole division up. It forces us to ask, what if, in the future, our most advanced, our most powerful, and our most useful materials are actually alive